Alright, so now we're going to be talking about the maximum depth of a binary tree. This is the second problem here in the trees category, and it's an easy problem. So maximum depth of a binary tree. In this problem we have, given the root of a binary tree, you see the root, return its maximum depth. So over here you can see we have this as 0 and then 1, and then over here we have 0, 1, and then this is 2, and then over here 0, 1, and 2. So basically over here we could see a binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So over here we have this root node, and then we have all the way to its leaf node. So over here we have 3, 9, then we have 20, then we have null, null, 15, and 7. So we have output as 3. What does that mean? Basically means 0, 1, and 2. It's counting this 0th root node as well. So that's why it's saying the longest leaf node, longest depth is from here all the way to here. Over here we have example 2, and over here we have input root is equal to 1, then we have comma null, then we have 2. So we have 1 comma null, and then we have 2, and then the longest is 2. Constraints: the number of nodes in the trees. The number of nodes in the trees in the range from 0 to 10 raised to the power 4. This is the number of nodes in the tree. So it could be from 1 all the way to 10 raised to the power 4. That's long. So we have minus 100 all the way to node value 100. So it's in between minus 100 and positive 100, the value of each node. Now, over here we have the solution. So we have to write the solution, and the solution is pretty simple. First of all, what we're going to do is we're going to have this definition of a binary tree node. So this is the struct tree node, and each tree node has a value. It has a left pointer and as well as a right pointer. It has a constructor. The constructor has the value that's set to 0, left pointer, and then we have right pointer, and then over here we have tree node parameterized constructor, which has the int value x, left pointer, and right pointer, and then we have tree node int x, tree node left pointer, and then we have tree node right pointer, and then we have value x, left node, and then right. So over here we have solution, class solution, and we have int maximum depth, and then we have tree node pointer root, and over here we have to explain it. Okay, so let's break this problem into a smaller problem. First of all, we need to find the maximum depth of a binary tree, right? We know what a depth is. You kind of like understand, like if you want to go downwards in a tree, kind of like a pattern, like like a recursive pattern. Okay, so first of all, you want to know whether your root is okay or not, right? So there's always a base case part. So take a note of this, that when we're looking at a tree and we have to go all the way to its leaf nodes, we want to do a recursion process. And whenever you're thinking of a recursion, you always have a base case situated first, and then you have to solve that. The base case is pretty straightforward. All we got to do is we have to find the maximum depth, right? So I would prefer this. We have if, so I'll say root is equal to null pointer. Okay, if that occurs somehow like that, we could just simply return null pointer. Okay, or we simply could just return 0. That means we don't have any maximum depth, right? Because the solution of this problem says that we need to return an int, that's why I have to return some kind of number. Okay, then we have the maximum depth. Okay, so we have to look at this root, and the root has, remember, it always has a left pointer and right pointer, so we have to go downwards. So basically I want to call this. I want to call this until I find return 0. Okay? Basically recursion, simple recursion that's happening. So I'm having left pointer, or I would say left depth, and then we call this maximum depth function, and we call the root pointer. So we have left depth, and we have maximum depth, and we have root, and then inside that we have the left part. Got it? And then the same goes for the right part. We have maximum depth. We want to go all the way until we find return equal to 0, right? We want to find until the null pointer is 0. So maximum depth, and then we have root pointer right, and then in here we have int right depth, and then this is root right. Okay, so we have left and right. We now basically need to find the maximum of each, right? Either the left depth or the right depth, and we just keep keep going towards the bottom. So I just keep constantly going down until I find some kind of thing. So I would generally return the maximum count, so the maximum of either the left depth or the right depth. Okay, so basically you're either returning the left depth or the right depth, and you want to add a +1 to it. So what it means is basically you're either returning left or right. You're going to add 1 to it because normally they start from 0, and you're going to just count as, because it was 2, right? Like 0, 1, 2, and then its total is 3. So that's why we're adding this +1. So let's just control and put a comma here and see what happens. Now you can see over here we have the accepted case 3920, null null 15.7. I guess it's this one. Output is 3, expected is 3. The second one is this one, which is 1 null 2, and output is 2, expected is 2. Perfect. My test cases match, so the test solution works. Now I'm just going to submit it using control and enter. So whenever I control and enter, it approves my solution, and it says that it beats 10.99% of users with C++. Okay, so that's really great. I mean, this solution is accepted. That's one of the solutions to find the maximum depth. Then again, you could find other solutions, but this is one of the solutions. Let's look at this in ChatGPT just at the end to see if we have a better solution here. So we go to chat.openai.com. Just one second, not here. So you can basically make an account with the ChatGPT. So I already have one. Okay, so what we're gonna do is we're gonna paste this solution. We're gonna say explain this solution in simple words. Okay, and let's see if we basically got the same explanation here or not. So it says the code is for finding the maximum depth of the binary tree, which means how many levels the tree has from the root to the deepest leaf. Here's what's happening. We start with a function called maximum depth that takes a tree node pointer, let's call it root, as input. Okay? Then what we do is, if the root is empty, it's a null pointer, meaning there's no tree. We return 0 because there's no depth. If the root is not empty, we recursively find the maximum depth of its left subtree and its right subtree. Once we have the depths of the left and right subtrees, we return the maximum depth among them, +1. The +1 is because we're counting the current level where the root is. Okay? So in simple terms, this function looks at a tree, checks if it exists, then returns how deep it goes by checking how deep its left and right some branches go, and adds 1 to the deeper of the 2 branches. So basically that's what it's saying. It goes all the way to the bottom, and then it adds +1 to basically accommodate the current level where the root is. Okay, and that's the 0th position, and basically that's the solution. Hope you enjoyed this explanation to the maximum depth problem for LeetCode.